All right, in this lesson, we are going to look at case 2 here for solving oblique triangles. Remember, in the last lesson, we looked at case 1, where we knew two angles and a side of a triangle, and we had to find the other three pieces of information. Now, those two cases, angle, angle, side, and angle, side, angle, we only were able to create one triangle. Okay, if we think about here, if we know a side length and then we know these two angle measures here, there's only one possible triangle that can be created from that information. Okay, the only thing I could do would be to extend this side out, extend this side out, and we would be creating a unique triangle. There's nothing else that I could do with that information. Okay, that's also, if you think back to geometry, why we were able to use just this much information to prove that two triangles are congruent. Because if I know two angles and a side in between, that creates a unique triangle. Something similar happens if I know two angles and a side not in between. So in this second case here, if I know two sides and an angle not in between those two sides, a few different things could happen. Right? That's why in geometry, this was not one of the ways that we could prove two triangles congruent. Okay, and we'll look at those few things that could happen here in a second. We could actually end up with no triangles. We could end up with one triangle, or we could end up with two different triangles. Okay. For this reason, this case where we know two sides and an angle not in between those two sides, it's known as the ambiguous case. Okay, so let's go through those possibilities here. I'll give you a demonstration. I'll give you a chart at the end to show you all the different possibilities, and then we'll run through some full examples. All right. So first, we're going to assume that the angle that we're given is an acute angle. So in this situation here, we're saying that we are given the measure of angle A, we're given the length of side A, which is the side opposite angle A, and then we are given the length of side B here. Okay, so those are the three pieces of information that we know. We know the side, angle. Now, we already talked about how we find this height here. Okay, we can call it an altitude or a height. We talked about that in the last section. We can just use B times the sine of A to find that height. So if this side A, the side opposite the given angle, is less than the height, we end up not being able to create a triangle. Okay, now let me give you another, maybe better visual of that. So let's say that we're given this information. We're given angle A is 50 degrees, side B is 12, and side A is 6. Now, we're not given an angle right here. So what that means is I could drag this side however I want. But we can see that no matter where I drag this side, it's not going to create a triangle. Okay, it's not going to connect with this bottom side here. All right, so, and that's our first possibility, right? If I take the sine of A times side B, that's going to be greater than this side. If that happens, we end up not being able to create a triangle. All right. Now, the second thing that could happen is if this side A is equal to the height. Okay? If that happens, we end up with one right triangle. Okay? And again, let's get a nice visualization of that here. So if I were to extend this out, I think that the sine of A times B is about 9.2. Okay, so that side then, okay, I would be able to create one triangle. We can see if we click and drag this side in either direction, we can't create another triangle. Okay, we can only create a triangle, one right triangle, like this. All right. The third possibility is we may actually end up being able to create two different triangles, okay? If the length of side A is bigger than the height, but less than side B, we can actually drag this side A and create two different triangles. Okay, so again, let's get a visualization of that. Let's make this side, I don't know, 10. So I could drag this over here and create a triangle that looks like this with those three pieces of information, right? 50 degrees here, 12 here, and 10 here. Or I could drag this over to here and create another triangle. Okay? Again, those same three pieces of information. This angle is 50 degrees, this side's 12, and this side is 10. All right? So, okay, that's the third possibility. Now, there's actually another possibility if angle A is acute here. If we make side A even longer, right? If it actually ends up being longer than side B, then we just create one triangle. Okay, we would just create one acute triangle all the way over here. Because if I were to click and drag this, it would end up not hitting this side until we get up to over here. Right? So again, a visual of that. We can say if we make this side something like that, right, where A is greater than B. Right, if I click and drag this, we can see that we're not going to create a triangle over here, but we will be able to create one over here. Right? So there are four possibilities if the given angle, angle A, is acute. Now, we actually also could talk about, well, what happens if this angle is obtuse? Be a little bit easier to visualize. So let's say that this angle is obtuse, and then we're given lengths for side B and side A. Now, if A is less than B, there's no triangle, right? This side isn't long enough to reach down here and create a triangle. Right? Well, the other possibility is that A is greater than B. Right? So if A is greater than B, it is long enough to reach down and create one triangle. Okay, so there's no way for me to swing this over here and create a triangle, because then we wouldn't be using angle A. Okay, so we actually end up with 6 different things that could happen here. Right? So here is a chart that summarizes all of this information. All right, now these are all assuming that we are given side A and B and angle A, but these are all the same idea if we're given two sides and an angle not in between, no matter what they're named. Okay, so if A is acute, right, we had these 4 things that could happen. Right? If A was less than the height, or B times the sine of A, no triangles. If A is equal to the height, which would be B times the sine of A, one triangle. If A is bigger than the height but less than the other side, we end up with 2 triangles. And if A is greater than or equal to B, we just get one triangle. And then the other 2 possibilities, if the given angle is obtuse, right, if the side opposite the given angle is less than or equal to the other side, we can't create a triangle. And if the side opposite the given angle is greater than the other side, we end up with 1. Now, note that these could all be, let's say, for example, we're given sides B and C and angle B. Okay, well, to use this information to test then, we want to think, well, here in this situation, we've got side A and then sine of the opposite angle. So here, we want to look at, if we're given this information, we could say, since we're given B and B, side B and angle B, we would want to test to see, well, is B less than C times the sine of B? All right. Or if we were given sides A, C, and angle C? Well, since we're given side C and angle C, those would be the two pieces we would put on opposite sides here. So we would test to see, well, is C less than A times the sine of angle C? All right. When we're looking at these tests here, we're comparing a side and the sine of its opposite angle. All right. That's how we're testing here. So no matter what pieces we're given, as long as we're given two sides and an angle not in between, this is how we would set it up. Okay. So we're saying side and its opposite angle on opposite sides of this inequality or equality potentially. All right, so let's run through a couple examples here. All right, so here in example 1, it says we are given angle A to be 32 degrees, side B to be 150 feet, and side A to be 100 feet. Okay, so first, let's just kind of sketch out what we have. All right, so I'm going to draw a triangle real quick here. Let's say we've got A, B, and C. So we know 32 degrees, and side B is opposite angle B, so that's 150, and side A is 100. Okay, so the first thing we're going to test here, since we can see we have this situation, side, side, and then an angle not in between, we want to test to see how many triangles we're going to have. Okay, the given angle is acute, so we know that we're going to be looking at the first part of our chart. So let's calculate B times the sine of angle A and compare that to the length of A and see what happens. All right. So B times the sine of 32 degrees, I guess I can fill in. So that'll be 150 times the sine of 32 degrees. And that will equal, so let's calculate that, 150 times the sine of 32. And remember, make sure that you are in degree mode. All right, so that's 79.5. Oops. So now, we want to compare that to our given length of A. Now, we find that A is greater than B times the sine of A. All right, so we end up with B times the sine of A is less than A, but A is also less than the length of B. Okay, 79.5 is less than 100, and 100 is less than 150. So if we look at our chart, okay, B times the sine of A is less than the length of side A is less than the length of side B. That means we're going to end up with two triangles. Okay, we're going to end up with two triangles. So I am going to go ahead and draw another triangle here. Let's move this down here. I'm just going to copy it and paste it, and I'll drag it over here. All right, so we know we have two triangles, and they're each going to have this much information. Now, one of them, angle B, is going to be acute. One of them, angle B, is going to be obtuse. Okay, but I'm still just going to draw them the same like this. So once we've determined how many triangles, we're just going to use the law of sines to solve. Now, if you remember, the law of sines says the sine of an angle over the sine of an angle over its opposite side is equal to the sine of an angle over its opposite side. So here we can say the sine of 32 degrees over 100 is equal to, now since we know side B, we'll solve for angle B first. So we'll say the sine of B over 150. So we want to solve for B. So the first thing I'll do is multiply both sides by 150. So we'll end up with 150 times the sine of 32 over 100 equals the sine of B. Well, now I still need to get B by itself. To do that, if we're undoing sine, I want to take the inverse sine of both sides. So what I'll end up with is the inverse sine of all of this. 150 times the sine of 32 all over 100, and that's going to be angle B. So we can put all of that into the calculator. Right, so inverse sine of 150 times the sine of 32, close the parenthesis, divided by 100, and we get about 52.6 degrees. Right, so that tells me that angle B over here is about 52.6 degrees. So I'm going to go ahead and fill that in up here. D2.6, oops. All right, and I guess we should be listing all of these out over here as well. Right, so A we know is 32, B we just found to be 52.6, C we don't know yet, and then side A is 100, side B is 50, side C we don't know. Okay, so now we want to use that information over here. Okay, once we find this missing angle, angle B, to get this angle B over here, what we do is take 180 minus this angle. Okay, so I'm going to do it in a different color over here. So this angle B is going to be 180 minus this angle B. So minus 52.6. So that will get me 127.4 degrees. Right, and we'll list them all up here as well. So A is 32, B 127.4, A is 100, B 150, and we don't know C yet. Okay. Now, we can easily find the third angle in each of these triangles. Right? Over here, we can say that angle C is just going to be 180 minus 32 minus 52.6. So that's 95.4 4 degrees. And I'll put it in the picture as well. All right, we can do the same thing over here for angle C. So we can say C is 180 minus 32 minus 127.4. And what is that? 20.6. So angle C is 20.6 degrees. I'll put that on the picture as well. So again, obviously my pictures aren't to scale here. Angle B should be obtuse. Angle A or angle C over here should actually be obtuse, but that's okay. We don't have to draw them to scale. Now the final piece we need in each of these is side C. So I'm going to have to use law of sines again for both of these. So what we can do, since we know that angle C is about 95.4, what we can do is over here say sine of 32 over 100 equals sine of 95.4 over C. So first, if I multiply the C over, C times sine of 32 over 100 equals sine of 95.4. Then we'll multiply both sides by the reciprocal, and we'll end up with C equals sine of 95.4 times 100 over sine of 32. And we can put all of that into the calculator. So sine of 95.4 times 100 divided by sine of 32. We get that C is about 187.9. So equals 187.9. And we have solved our first triangle. Now, let's finish out the second one here. We'll have to set up another law of sines situation to solve for side C here. So we can say, we can use that same first ratio, sine of 32. Actually, let's do this in blue to stay consistent. Sine of 32 over 100 equals, so we'll have sine of 20.6 this time over side C. Now, another way of thinking about solving something like this would just be to cross multiply. So if we do that, we end up with C times the sine of 32 equals 100 times the sine of 20.6. Then we would just divide both sides by the sine of 32 and get C equals 100 times the sine of 20.6 all over the sine of 32. And again, put that in the calculator. So this is almost the same as my last entry here, except this is 20 point, oops, yeah, I'll just type it all in again, sine of 20.6 times 100 divided by sine of 32. and we get 66.4. So here, side C is 66.4. That was a long problem, right? We ended up having to first figure out how many triangles we had. Then in this case, we had to solve two different triangles, right? If we end up having to solve two different triangles, the key is once I solve for that first missing angle, angle B in this case, to get the angle B in the other triangle, we just take 180 minus that angle B, right? And then use law of sines to solve both triangles from there, all right? So let's take a look at another possibility here, all right? So in this example, okay, we have the same situation. We have angle A, side A, so an angle in its opposite side, and then another side. So let's sketch it out. So we've got this triangle here. We've got angle A, angle B, angle C. So I know this is 50 degrees. The opposite side is 8, and then the opposite side to angle B is 15. So the first thing we need to do is determine how many triangles. All right? So we want to first calculate B times the sine of A. Right? So B times the sine of A, that's going to be 15 times the sine of 50. So, go to the calculator. 15 times the sine of 50 degrees is 11.5. Right, so we get that this is 11.5. So that's essentially saying that this height is 11.5. Well, we said if this opposite side is less than that height, there's no way for me to drag that side and create a triangle. So if this is the case, and remember we can just refer back to our chart, right? If A is less than B times the sine of A, no triangles are created, okay? We can just say no solutions, and that's the end of the problem, all right? If we realize that there are no triangles, we're done, all right? Let's look at one more possibility here. All right, so in this triangle, we've got angle A is 40 degrees, side A is 20, and side B is 15. So let's sketch it out first. All right, so A, B, C, 40 degrees. The side opposite angle A is 20. The side opposite angle B is 15. So first, let's test to see how many triangles. So right off the bat, I actually notice that side A is larger than side B, okay? If I notice that, I don't even have to calculate anything, right? If we, again, go back to our chart, if the side opposite the given angle is greater than the other side, we know we're going to have one triangle, right? So we can go ahead and start using law of sines, right? So I can say sine of 40 degrees over its opposite side, which is 20, is equal to, now in this case, I'm going to be solving for the sine of B first because I know its opposite side is 15. So multiply the 15 over. 15 times the sine of 40 over 20 equals the sine of B. Now to get B by itself, remember we need to undo sine, so that means taking the inverse sine of both sides. So what we will end up with is all of this inside of the inverse sine function, and that'll be angle B. So we can just type all of that in. The inverse sine of 15 times the sine of 40, close the parenthesis, all over 20. So we get that this missing angle is about 28.8 degrees. So 28.8. And again, make sure somewhere you're organizing your answers like this. Now, to find angle C, all we need to do is take 180 minus the two given angles, or two angles that we know already. 180 minus 40 minus 28.8 will be 111.2. So 11.2, and I'll also write that in here into my triangle. And then the only thing we have left to solve for is side C. So let's set up another law of sines. I can still use this first ratio. Sine of 40 over 20 equals sine of 111.2 over C. So cross multiply, get C times the sine of 40 equals 20 times the sine of 111.2, divide by the sine of 40, and then we just need to put that into the calculator. So 20 times the sine of 111.2 divided by sine of 40 gets me 29.0. So C equals 29.0. And we're done. Okay, so for these problems, when we recognize that we have two sides and an angle not included, the first thing we have to do is test to see how many triangles, okay, using this information. I would definitely write this information down somewhere in your notes. Right? Once I've tested to see how many triangles, then we just use law of sines to find each missing piece, along with the idea that each angle, or all three angles in a triangle, add to 180. All right. Now, since this was certainly a longer lecture, we'll say that this is Monday's work, and then Tuesday's work will just be practice problems for this. All right. Please send me any questions that you have.